Hello, fellow Scratchers! When I began this simple Raycasting series, I intended it to be no more than 2 episodes. I was very clear. There was no way we would be adding textures to these walls. It's too complex, and well, bitmap Raycasting in Scratch is far too slow to handle it. Well, here we are now in episode 7 of this epic series, and yes, today we are adding textured walls. Oh man, I will not be able to live this down, but guys, you should never underestimate what is possible in Scratch, right? So what changed my mind? Well, firstly, we made huge progress on boosting the speed of our Raycaster in the previous episode 6, far surpassing my expectations. And secondly, the recent breakthrough in fast image scanning, see last week's ultra-fast scanning tutorial. With this in hand, the final obstacle was out of the way, and so here we are! But before we dive into coding, let's have a quick chat about how texture mapping works in a Raycaster like ours. So, what is a texture? Okay, so here's our lovely level that we drew in Scratch. This is a top-down view, but if we were to angle it and heighten the walls, whoo, that's a little bit too much, but well, bear with me. The little square up here is a texture, and when placed end to end, it produces a seamless, repeating pattern. Perfect for plastering all over the walls of our game. Wow, that looks cool. But obviously, the walls in our game are not this tall. There, let's go for this height. Now, to apply the same texture to this wall, we need to repeat it many more times in the same space. So the takeaway from that is that the wall height will be very important to us. But how do we decide where on a wall the texture should start and end? For this, we are going to use the simplest method possible. We'll divide the map up into a grid of squares. Each square is the size of the height of our walls to match the size of the texture. Now, we raycast. As a ray collides with a wall, rather than just recording how far away the wall is and its colour, we now want to record the texture at this point too. In this example, we work out how this point maps to our texture. We simply find out how far across a grid square the collision occurred, and this gives us an index into the texture, and tells us which vertical slice of texture we are going to need to paint. This index is therefore the data we need to store in our raycasting list, so that when later on we begin drawing our scene, we can look up each texture line in our textured list, and colour by colour draw out a slice of texture one at a time. And that's pretty much everything you need to know to get started. So I am dead excited to go. Come on, let's get scratching! To begin texture mapping, what we need are some textures, right? And a way of scanning those textures into a list. Well, haha, luckily the last tutorial I made was on ultra-fast image scanning. A coincidence? I think not. Now, I don't know if all of you have managed to code that little project up, but if not, then don't panic, because for your convenience, I have released a project named Raycaster Episode 7 Assets on my tutor account. You'll find a link in the description under the video. And not only does it contain some fine example texture assets, but it also includes the completed scanning scripts all ready to go. So, if you want to use your own scanning scripts, then go ahead. Just note I've made a couple of changes, so let me just go over them quickly now. Firstly, when the scanner is used, the first thing we do is switch to a new costume, Texture 32. This is the costume that contains our textures. Look at these beauties. Cool, right? And this is left on screen using a second clone that wasn't in our original scanning scripts. Then, rather than triggering the actual scan off the space key, I have just added a weight 0, and then gone directly into the scan scripts right away. The next change is the addition of a delete this clone under the scan complete event receiver. This way, after the scanner is complete, we tidy up any clones that are hanging around. And lastly, if we head over to the define initial scan script, we are setting X now to negative 239, one more than the original minus 240. It turns out that this is the preferred starting position for pixel perfect scanning, and yes, we do need to do the same in the second scan script too. Cool, so that is all the changes that I've made. Feel free to do the same in yours, or if you want to continue with my scripts, then just open up your backpack and drag the entire scanning sprite into there. You'll then get the textures for free too. So now we can open our Raycasting projects, and we will continue from where we left off in episode 6. But before we begin, to ensure we don't lose any of our hard work, Make sure to first save this as a new copy, for this is episode 7, yeah! Next, open up your backpack and drag out the scanner sprite into your sprites panel. As you know, this sprite comes with a number of textures already in place, so to scan these textures into the scan list, all we need to do is click this Begin Scan Event block. And there it goes. You can see the screen scanning in progress. This should take just around 10 seconds to complete thanks to this awesome new scanning scripts. Once done, we can check out the scan list content, and you'll see it's scanned 172,800 coloured pixels. That's a full 480 by 360 scratch screen. Cool. Next, bring up the costume we just scanned. Here it is in the costume editor. Now, don't hesitate to try your own textures in here. I only provided these so that you had something to get started with. All my textures are 32 by 32 pixel squares. Just make sure they all line up like mine, and you'll be rocking. What you might notice, if I zoom back out, is that I'm only using the top portion of the canvas for this textures. As such, all the rest of the area will end up wasted space in our scan list. Since this is such a big list, it will be worth reducing the size of the scan to save on memory. So in the scanner sprite, make a new variable naming it texture size, keeping it for all sprites. And we will set this to 32 before we begin our next scan. All my textures, as I had said, were 32 by 32 pixels. But if you're using your own textures, then this can of course be any size you need. Next up, scroll across to the Define Initial Scan script. The full screen height is 360 pixels, but now I'm going to reduce the scan to only scan the height of 2 texture squares, that is, 2 multiplied by texture size. And the same must be copied into the Define Scan script too. Cool, we are set. So come back over and click the Begin Scan script again. Perfect. This now scans faster, and the result in the scan list is only 1/5 of the size. Good job. Now that we have our textures all squirreled away in the scan list, we can shift our attention to creating our texture mapping grid. Click into the Raycaster sprite and find the Define Single Ray script. As we all should know by now, this is where we fire off a ray across our level, and by the time we get to setting the distance here, the ray will have collided with a wall. So now we need to calculate this sprite's position relative to the texture grid. Split off the if touching level color. And then make a new variable naming it texture offset for this sprite only. And for starters, just set texture offset to the X position of the collision. Cool, return the if touching script. So previously we were setting the entire wall to just one of 2 colours, these colours being defined just here and here. Obviously these colour values will no longer apply if we are adding textures to our walls, as the texture gives the wall colour. So instead of storing the colour here, we will now store the texture offset. But remembering the first 9 or more numbers are reserved for enemies and collectibles, not walls, so how about we add 100 to each? Okay, here we go then. Let's run the project and see what we've got. Oh wow, look at this! We are in Rainbow Land. The colour of each vertical slice of wall is now governed by its X position on the level. So the further east to west we travel, the bigger its colour value. That's pretty neat. And oops, oh gosh, you'll notice we have walls of francs. This is because I forgot we'd be having negative X positions being added to our list, so that the plus 100 was not quite enough to stop this happening. Not to worry. The important thing is that we can see the position of the collision as a colour. So what we are going to do next is take this X position and place it in a mod operator block. This will give us the remainder of the X position after dividing it by the right-hand number, in this case 25. And here is the result, a beautiful repetition of gradient squares. The length of these squares is 25 pixels on our level costume, so for a perfect square, the height of the wall must be a matching 25 pixels, right? And yes, that is correct. Look in our pen sprite. We calculate the wall height here. The top wall is positioned at 1.5 multiplied by height, above the middle of the screen, and the bottom is 1 height below. Add these two lengths together and we get 2.5 multiplied by height. But then finally we notice that we are already multiplying height by 10 up here, so 10 times 2.5 is, you guessed it, 25, the height of our walls. Cool, so back in our Raycaster sprite and this mod block. Why does modding by 25 give us this nice repeating pattern? Well, the mod operator returns the remainder after division, so with an x position of 60 and a grid size of 25, 60 divided by 25 gives us 2, remainder 10. But this is great! 10 tells us just how far across this grid square we have gone. Yes indeed, mod is exactly what we need for our texture mapping. But before we continue, you may have noticed this nice repeating pattern is not continuing on every wall. Do you know why? It's because we are only calculating this offset using the x position of the collision. This gives us the texture on walls running east to west, but not north to south. Those would require the y position. Well, easy fix. Bring in an addition operator and sum the x and y positions together. Then pop that back into the mod operator and check this out. Oh yeah, now we are really tripping. The entire level is pasted with multicolored squares. That's quite amazing. So that's almost done, but there is one problem. The texture offset value returned from this mod will be a value between 0 and 25, the height of our walls. But our textures are 32 pixels wide. To render correctly, we are going to have to translate from one scale to the other. The maths is easy enough. We begin by dividing by 25, the wall height. We can be a little clever here and just divide the x and y positions first, because then we can mod by 1, since the left side is already 25 times smaller. Great, now we just need to multiply the number back up by 32, our texture size. So set texture offset to, but be careful here, to ensure all our numbers work out, we should use a floor block to round the number down to the nearest whole number. And then drop in the current texture offset multiplied by texture size. And that's it. Our texture will have been scaled to the correct texture size. We can run that again, and you should find that our colours are just a little bit more vibrant now, as the colour range has been increased. So we are practically ready to begin coding the texture rendering now. But just before we do, it would be good to consider this touching level colour check. This was designed to let us change the colour of the walls that face different directions. Well, even when texture mapped, it will be useful to see this distinction. So for the second draw, let's add 1,000,001. That's 1 with 5 zeros and another 1 on the end. I use this large number because our scan list can, in theory, contain 172,000 items, so to be safe I'm using an offset of 1,000,000. The extra 1 on the end is because the texture data in our scan list begins with 1, not 0. The draw above we set to 2,000,001. 2 with 5 zeros and a 1. Cool, we can work with this. Looking at the running project, things are looking fine to me, so on we go. Click into the pen sprite and find the define draw row block. It's time to do some texture painting. Scroll down to where we are setting the pen colour. Now we're really going to pull this script apart now. Firstly, we won't be needing either the set pen colour or brightness blocks, so move them out of the way. But keep the go-to XY. The blocks below are responsible for actually drawing our wall. We pen down, move the sprite, and pen up to complete our simple coloured line. But our textured walls are made up of 32 equally sized sections of colour. So instead of drawing them from top to bottom in one go, we must split the journey up into 32 pieces and draw them one at a time for each colour in the texture. We'll begin with the pen down as before to begin our line. Then repeat for texture size iterations. Our 32 pieces, yeah? And then we pen up. Now we want to gradually change Y, so instead of this set Y, we use a change Y by. Right, next problem is now how far to move by. Let's calculate the actual height of the full line we want to draw. Under the go to XY, set height to height multiplied by 2.5. That accounts for the 1.5 up and 1 down that we draw. Then, to account for the extra pen width, res, we subtract res. That's the full height of the line then. But we want to break this up into 32 smaller steps. We'll make a new variable to hold this, naming it dy, for this sprite only. And because we are drawing downwards, set dy to 0, subtract. And then we divide height into texture size pieces, that's 32 equal pieces. Great, because if we now change y by dy, then after 32 repeats, we will have moved the full distance again. Yeah. But just before we draw each line in our loop, we now need to decide each line's colour. Bring back the set pen colour. So type used to be a colour, but now we have switched it to be a texture offset, the one currently giving us the nice tiled gradient. So how do we map this to the texture stored in our scan list? Well, we'll need to set the colour using an item of scan list for sure. But what item number? Make a new variable naming it scan index, or IDX for short, for this sprite only. So the type variable holds our texture offset, but remember we added 1,000,001 to it. We need to get back our original offset without the millions. So set scan index to type mod 1,000,000, 1 with 6 zeros. Easy, gotta love that mod block. Right, let's explain how this offset is going to work with our scan list. Here is our scanned costume, and all of the colours are stored in the scan list from top left as item 1, running across and then starting again on the next row as item 481, since there are 480 pixels in a full row. The scan index variable will be a value between 1 and 32, representing how far across the texture we need to reference. So we begin with the colour at scan index, and then to find the colour below this one, we just need to add 480 to the scan index. Simple. This process repeats down the texture until we have picked out all the colours one at a time. Cool! We are close to being able to test this. But one word of warning. You'll note we didn't set the pen colour before we did a pen down at the start. That is a little dangerous, as it could lead to a dot of the wrong colour. So let's get around that by setting the pen transparency before the pen down. Oh my, look at the stage! Something exciting is going on over there. Ha! So yeah, they set the transparency to 100, fully invisible. The initial pen down will then do nothing at all. But, look at this. The walls have mysteriously all gone transparent now, so something is wrong. And you know what? I know exactly what the problem is. It's our set pen colour block here. This is not the right one. I just used the previous one. Look, it takes a colour number. So this one just sets the colour hue, leaving the transparency as it was, which is why it's now invisible. But we wanted to set the entire red, green, blue colour value, and for that we need the other set pen colour 2 block, with the colour swatch. This one also sets the transparency back to non-transparent as well as the colour. So drop the item of scan in there, and throw away the old set pen colour block. Yuck! But guys, are you seeing what I am seeing over here in the project window? This is so amazing! Let's have a walk around. Wow, it just blows me away that we could have something like this working. The texture is mapped beautifully onto our level walls, shrinking off into the distance, and with a frame rate of 20 even now, and that is quite something. Wow. Perhaps the only thing missing is that we've lost our lovely darkening of the walls as they move into the distance. This set pen brightness block over here is how we used to achieve this, but if we were to drop that in after the set colour, you'll find the results are very unsatisfactory. We do get the darkening effect, but all our colours are messed up now, and that's because the red, green, blue colour we set has a brightness built into it. After all, some shades of a texture are naturally lighter or darker than the others, but if we use the set pen brightness block, We override this and all shades become a uniform brightness across the entire texture. Double yuck! So to fix that, we use the change pen brightness block. Yeah, it's not quite a straight swap in though. We need to change the 120 down to be 35, and the divide by to be divide by, say, 2. There, that's pretty cool. Perhaps a little too dark. If you think so, you may want to try dividing by 3 instead. Yeah, I'm liking that. What do you think? Okay, we can optimize this a tiny bit. See how we are calculating this brightness value each time around this repeat loop? Let's just do it once before the loop begins. Make a new variable named bright for this sprite only, and set it to our 35 subtract distance divided by 3. We do this before our repeat loop, and then drop the bright variable into the set brightness block. Excellent. That should work just the same. Yeah, cool. So how about we also restore that extra feature that darkens the walls facing in different directions to show up these corners better. We recorded the wall direction by adding 1,000,000 or 2,000,000 to our type variable in the Raycaster sprite, remember? So back in the pen sprite, check if type is greater than 2,000,000, 2 with 6 zeros. And if it is, change the bright variable by -15 to darken it just a little. Drop that in just after the set bright block, and you can see the right-hand wall is now just that little bit darker, and the corner is much more visible. Nice. Feel free to play with this value to find a brightness that you are happy with. Walking around the level, I found that -15 is a good compromise. Not too distinct, but enough to make the corners stand out. Okay, this next one is interesting. The texture mapping works great like this, but we are doing too much work. Look at this far off wall ahead. If we zoom in on it, you can see that we are still drawing our texture by splitting the wall height into 32 pieces, regardless of how tiny the wall becomes. If I zoom back out and adjust res so that our pen lines are 10 pixels wide, would we not expect the height of these walls bands to roughly match the same width, 10 pixels high? Yeah, I think so too. The benefit of this is that it will make the whole engine run faster. Less looping, faster engine. Plus, this is a common feature in 3D engines. Swapping out a high-res texture with a lower quality texture as it moves further away is called MIP mapping. Now, we aren't going to be implementing things to that degree, but instead we'll stick to a simple pixel skipping in powers of 2. That is, 2, 4, 8, 16, 32, etc. So our aim is to be able to scale back the number of times we repeat here. Make a new variable named scaled texture size for this sprite only. And we'll now be repeating by the scaled size instead. To set this value up, temporarily move off the repeat loop into some space. So this scaled texture size is the number of coloured segments we want to paint. We could work that out by dividing the wall height by res, our pen width. Then bring in an if-else, because we need this value to be a power of 2. So if the scaled size is less than, say, 12, then we set it to 8. That's a power of 2 less than 12. Now duplicate that if and put it inside the else branch. This time checking if size is less than 24, that's double of 12. If it is, then we set it to 16, the next power of 2. Duplicate again, checking size being less than 48, and set it back to 32. And lastly, if it's not less than 48, then just set it to texture size, and let it be full resolution. That's fine. Cool, we have our desired scaled texture size then. Now, if the scaled texture size is smaller than our actual texture size, we will need to know how many pixels we are skipping each time around the repeat loop. Make a new variable named skip for this sprite only, and set skip to the result of dividing texture size by the new scaled texture size. But just in case your textures are not sized in powers of 2, wrap the divide in a floor to round it down to the nearest whole number. Great, now that we have skip, everything we do can be multiplied by this. Starting with dy, the distance we move by, setting it to dy multiplied by skip. But also this scan index. This too needs to now increase by 480 multiplied by skip. But we can save having to do this here by instead multiplying skip by 480 outside of this loop. Set skip to the result of multiplying skip by 480. And then finally we can replace the 480 here with our new skip value, before stuffing the repeat loop back on the end down here. Oh, that was hard work. Well, it's done. Our textures now scale. Notice how the far away wall is now constructed from far fewer pen lines. Speed-wise, we've gained perhaps an extra 5 frames per second. It's not a huge deal, but it's something, and I'll leave it up to you to decide if this last optimization was worth the extra effort for you. As we walk around, you can see how the texture gain resolution as we move towards them. That's so cool. Increasing res to a wider pen width, and the vertical texture changes in line, and that feels more consistent. Now hold on a moment, did you see that? This is rather disturbing to see. When we get close to a wall, the textures suddenly go mad, warping horribly. Ugh. This is caused by us relying on Scratch to position our pen, and not remembering that Scratch will try to prevent us drawing off screen. To fix it, scroll up in our scripts to where we first positioned the pen with a go to XY. We're going to stuff this Y value into a new variable, naming it simply Y, for this sprite only. Then before we go to XY, set Y variable to, and move the expression from the go to Y below into the Y variable above. Like so. Now, we can use this Y variable in the go to. Super, but we still have the same rendering problem. Okay, hold your horses. Scroll back down to our repeat loop, and instead of changing Y by dy, drop in a change variable Y instead, changing that by dy. Then we can once more replace the change Y position block with a set Y position, and pop in the new Y variable. And aha! A miraculous change! Our terrible wall warping has been fixed. Nice one. Well done. That's so much better. Walking around this maze now is really quite something. We've come a long way since our episode 2 days. Of course, I know what you'll be asking next. What if we want to use different wall textures? Ha! You read my mind. Shall we? Click into the Raycasting sprite and find the single ray script, of course. We set our texture offset just here, and this, if you remember, is just an offset into the scan list. Now then, if we want to use the next texture, don't we just have to add 32 to this number? Yes, of course, any multiple of the texture width. So easy. So change the texture offset by the result of multiplying texture size by, well, try 1. Ooh, did you see that texture change? Amazing. How about number 2? Oh yeah, this is fun. Number 3? Oh man, this is a really cool texture. Thanks to opengameart.org for these amazing textures, by the way. What an amazing resource. Yeah, so nice. It even looks good at lower resolutions too. There are simply loads of these to have a look through. So if you look at the texture costumes, how do we get access to this second row of textures? No problem. Just a little maths. We need an addition block on the left is the column number of the texture, then on the right, a multiplication by 480. And the number on the left of the multiply is the row number. So now we can access the next row number 1 as well. See? And if we wanted this TNT, well, that's row 1 and column 1, 2, 3, 4, 5, 6, 7. And there it is. Woohoo! We are unstoppable now. I guess that must be the end of the episode. What? What's that? You want to know if it's possible to have more than one texture on the same level at once? Oh man, what do you like? Okay, so yes, it's possible. Let me quickly show you how it can be done. The best bet is for us to start by duplicating the level sprite. Again, yes, I know, we are getting quite a lot of these, aren't we? And we'll rename it Texture 2. Now, in the costume editor, using the rectangle tool, I'll draw a filled shape over all the parts of the level that I want to be the new texture. As a hint, you may want to group the entire level before doing this, as it will make the next step easier. Ha! Because now you must delete everything else that is not to be in the new texture. See, this would have been so much easier if I'd grouped it to begin with. Right, with that done, come back into the Raycaster sprites code. And here we are in the single ray script once more. Now locate the change texture offset block. This is us choosing our texture. So we need a new if-else block, and we'll check whether or not we are touching the new texture 2 sprite. Then we can duplicate the change texture offset block into both the then and the else branches of the if. And you see we can now choose between the two textures depending on whether the wall is within the texture 2 area or not. And now I'll keep the special texture the same and change the default texture numbers in the else. And there! I have two different textures visible in-game at the same time. Amazing! This is just too good. Let's find that pillar room. Oh, sweet! Would you look at that? Right, I gotta try a few more combinations. Oh, nice. That's quite alien, isn't it? And with this back wall texture, man! Wow, I'm digging this pairing. I think we just need to play with the floor and ceiling colours a bit, and this would be amazing. I can only begin to imagine what you guys are going to do with this, and how awesome your Raycasters are going to look once you have texture mapping in there like this one. As always, you'll find a link to the Raycasting studio in the description under the video so that you can share your projects there. I can't wait to see them. But I am afraid we've come to the end of another epic episode. If you enjoyed watching, then please smash the like button, and if you haven't already, subscribe to the channel before I cry. You know you want to. If you are a keen fan or an educator, then please consider joining my channel membership. You get all sorts of perks, including, if you want it, access to the finished projects themselves. So cool. It just remains, though, for me to thank you for watching. I hope you have a great week ahead, and scratch on, guys.